All right, so it's 6 p.m. Let us start with this event, right?
Yeah, sure.
Pranav.
Yeah. Hi guys, good evening. Hope all are doing well. So this is Python Sprint 3, which will be a basic section, and this is the last basic section of Python, which we're gonna conduct. And we are very much glad that we have received such a good response for even Python Sprint 1 and Python Sprint 2. And we'll be concluding the basic section with Python Sprint 3. And we'll be going to Introduction to Data Science from the next session onwards, where you will see how data science is related with the Python. For now, I would like to call upon Ashwarak to please introduce himself.
Yeah, sure, Kirti. So I hope I'm audible now.
Yeah, you're audible, Ash.
Yeah.
Okay, great. So hello everyone. I once again welcome to this Python Sprint 3 event, right? So I'm Ashwin Bharat. I'm an aspiring software engineering, specializing in web development. I'm from Jain University as well. I've built like various web applications using MERN stack, and I'm currently building a project for our college as well, where students can ask and answer questions. It's called jQuery. Apart from that, I'm also a polyglot programmer. I'm really good with several other languages like C, C++, Java, Python, as well as JavaScript. And I'm also a blogger. I've written numerous blog posts on Python as well. So whatever was covered till now, right? The basics of Python operators. I've already posted several blog posts on them on Medium and several other blogging platforms. And I'm also the chapter leader for Code Academy JU chapter, where I also taught 500 plus students how to code in front-end technologies previous year. And hope to see you all over the follow-up events as well. So yeah, that's a bit about me.
Thank you, Ashwin. It's very nice. Now I would like to invite Sharanya to please speak.
So, hi guys, I'm Sharanya from Data Science Specialization. I'm doing my third year in Jain University. So, I'm the Data Science chapter lead. I'm the Data Science lead for the Code Academy chapter. Hope you'll all enjoy the event.
Okay, guys, that was about the data science team. Now I would hand over the session to Pranav, who will be teaching you the basics of Python. I hand over the session to Pranav to please introduce himself and continue the session.
Sure. Thanks, Kirti. I'll just share my screen. I hope the screen is visible, right?
Yes, Pranav.
Yeah, thanks. So, hi guys. For those of you who are joining us for the first time, welcome. And for those of you joining us again, thanks for coming again. So, this is the Python Sprint 3. And so, the agenda for today's session will be that we'll cover different control flow statements, like all the conditional statements, like if else, and different loops, like the for loop, while loop, and the different parts in it. And we'll go for the basics of a user defined function. So that will introduce us to functions, and later on we'll have different events following up related to the data science part. So we're going to start the data science track also. So just keep tuned. And so I'm Pranav. I'm a third year data science student at Jain University, and I'm also the part of Code Academy and other clubs like Google Developer Student Clubs. So I'm also passionate about Python programming, data science, Azure, Microsoft Cloud, and machine learning and deep learning, etc. So let's get started with the session today. So yeah, first we'll see about the different conditional statements present in Python. So Python conditional statements, as you all know, I think many of you will be familiar with the if-else part. So Python supports the following logical conditions in general mathematics. So in the previous event, when we were discussing about different operators in Python, we saw that we have different operators like equals to, not equals, less than or equal to, greater than, and greater than or equal to symbols, right? So basically, these conditions are used in these so-called if statements and loops. So when we use these conditions, we basically forming what we call as a conditional statement. So if a certain condition is true, then we execute whatever the code we written in the if body part. So as we all know, the if statement is written by using the if keyword. And let's just take a quick look at that in the Jupyter notebook. So yeah, we've basically declared two variables A and B, and we're using the if keyword here. So we're saying that if this condition, what the condition is that if B is greater than A, so we know that B is actually greater than A if you just see it in a general case. So if that is true, then this following body part is executed, right? So we're saying that if B is greater than A, just print that B is greater than A. If we run this, we'll basically get this. So it's like a very basic part, as we all know about this. Then we'll go to the indentation. So indentation is basically a very important part in any programming language. And I think even those who are practicing Python for a long time, they make simple mistakes in the indentation while running their codes. So what is indentation? Right? So indentation is basically these white spaces, or how you arrange different code blocks in your code that basically tells the Python that in a block, when you keep proper white spacing, then you will execute a sub block and then come out of the loop. So if we'll just see this in the Jupyter notebook. I think it will be more clear. So for example, in Jupyter notebook, if as you saw in the earlier example, we have this white space, if you can see, between the if body statement, right? So basically, if we do not have this white space here, as we see here, for example, I gave the if keyword, I declared two variables, I gave the if keyword, a condition, and the body of the if without any white space. So here, this is basically saying that we do not have any indentation, right? So if we print this, you will obviously get an error. So let's check it. Yeah. So this error is called as an indentation error, right? Because it says it expected an indented block. So if I just keep space here and then execute it again, then the code will be successful. So this indentation or this white spacing, whatever is there here, I think it is very important for us to just keep an important note, because whatever code you execute, even if it's a basic code or any advanced level codes, indentation will give you so many errors, and it's a very big headache if you just don't take care of them, right? So after the if statement, we saw the indentation part, and now we'll go to the elif, right? So the elif is a keyword in Python saying that if the previous conditions in the if keyword is not true, right? So we do not execute the part of the if body part. Then you come to what is called as an elif keyword, and you just execute the elif part. For example, if you see here, we declare two variables, A and B, and we say that if B is greater than A, then just print that B is greater than A, right? So as you can see, I am very careful of the indentation part here, the white spaces. So then if this is not true, for example, if B is greater than A, then this will be executed. But what if B is not greater than A, right? What if this condition is not true? Then you go to the next part, which is called as the elif keyword. Else if A is equal to B, then print that A and B are equal. So if this is true, then this will be printed. If it is not true, then we'll go to the elif part, and that will be executed. So we'll see that. So yes, we know that these both are equal, and so B is not greater than A. And so it goes to the elif keyword, and this part, A and B are equal, is executed here. So as you can see, the first condition is not true, and the second one is true. So the elif part is printed. And next we have the else, right? So we have if, elif, and then else. So what is else? Basically, else is a keyword which catches anything which isn't caught by the preceding conditions. So simply put, if you have an initial condition beside if statement, if that's not true, it goes to the elif part. What if the elif condition is also not true, right? There has to be some execution for the statement. Then we'll go for something called as else. And the thing about else keyword is that you do not specify any condition beside else. You just keep it as else, and you just give a body part. For example, print the certain statement. And so if nothing in the preceding conditions is true, it will directly just do whatever you give in the else keyword, else condition. So if you can see the algorithmic flowchart here, if the if condition is true, then it will directly execute the body of if, which is well and good. And then we'll end the control statement there. What if the if condition is false, right? Then as we saw earlier, we'll go to the elif part. And if the elif part is true, then again we'll go and execute the body of elif. And then the control statement is ended there. What if the elif part is also false, right? You don't have any other option except to execute the body of else. So as you see in this diagram, you do not have any test expression of else. So there is no proper condition for it. If none of the above is executed, you will directly go to the body of else and that is executed. So you'll come to the end. Let's see this in the Jupyter part. So yeah. So as you see, we have two variables and three green keywords. If you see, that is if and an if condition and the if body part. Elif, elif condition, and the elif body part. Else, and we don't have any condition here. So we'll directly have an indentation block and the else body part. So what happens here is basically, if this is not true, then you go to the elif part. If this is also not true, then directly A is greater than B, that will be printed. So let's see this. So as you see, 200 is, so 33 is not greater than 200, right? So this is false. And 200 is not equal to 33. So this is also false. And so the last option you have in this statement is the print that A is greater than B. That's it. So then we'll go to the nested if part, right? So what is nested if? Basically, you can have an if statement inside another if statement. This is what we call as nested statements. You also have something called as nested loops, like nested for loop, which you'll be seeing in the future. So basically, nested if statements or nested for loops or nested conditions, these are basically an advanced part where you have to see properly what condition you're specifying. Because for each if part, for example, let's just say, check this nested if statement, right? So you give a test expression for if that is true, the body of if is executed, and then the statement below if is also executed. So essentially, I think instead of this flowchart, it will be easy if you can just see the Jupyter notebook here, right? So observe carefully, guys. We have a variable x declared as 41. And then we have the normal if statement, right? If and an if condition and the body of if. But under the body of if, other than printing a statement, we also included another if loop, if statement here, right? So this is basically a nested if statement because we have an if statement under the body of an if statement. So if this is true, then we go to the execution part. And then after executing the print statement, this if statement is also checked and executed as follows. We have an if else under the proper main if block. So as you can see, guys, we talked about indentation, right? So these indentation white spaces and blocks are really helpful when you actually go for these nested loops or any advanced codes. So for example, if I just run this, so we have about 10. So this part is executed and also about 20. So this part is also executed. So we have 41, right? Let's just check it in a general manner. 41 is obviously greater than 10. So this condition is true. So then we basically print that about 10, right? X is about 10. And then after printing the statement, we also check for another if statement. So if X is greater than 20 also, right? We have X is 41. Is 41 greater than 20? It is true. So this is also true. Then execute that it is also above 20. Else, if this was not true, for example, if this was less than 20 or something else, if this wasn't holding true, then we would get that, but not about 20, right? For example, let's take a number like 19, right? So it is basically about 10, but it is not about 20. Let's see what will happen if we execute this. There you go. So we have, this is about 10, is printed here. But then if x is greater than 20, which is false, right? 19 is not greater than 20. So then it directly goes to the else part and prints but not about 20. That is how we'll have the different nested if statements. So then we have the pass statement, right? So for example, when you're executing a code, what if you don't want to do anything with it, right? You just executed the code, but you don't want any condition to be executed. It's just like a dummy thing, right? For example, you might be running a long code, and in the long code, you just have an if statement without any body part. But the thing is, you do not want that if statement to be true. There are two ways you can you can basically surpass that, right? One is just comment the if loop, if condition. The other thing is you use what we call as a pass statement. So if the if statements cannot be empty, right, you will get an error if the if statement is empty and it is run. So you just, for the pure purpose of avoiding getting an error, just to execute it without any output, you'll use what we call as a pass statement. Let's see this. So we have two variables here. We have an if condition, but here we use the keyword pass. So there is no output generated, right? We are not printing anything. We are not just checking for anything. We don't even have a nested if statement or something. It is just the keyword pass. Basically, we use this keyword pass statement whenever we just want to use this as a dummy part, right? It's just a dummy variable. So it generates zero output, right? It doesn't generate any output. For example, if I run this, there you go. There is no output generated. But the thing is, this if statement, whatever is there, if this is useless in our proper code, we just skip that part by using the pass statement. So pass is literally passing it out. So there is no use or no output. And then we'll go to so this is about the conditional statements, guys. So we have if, elif, else, and we have, we saw the keyword pass statement, right? And we also saw the nested if statements. This is what we call as the conditional statements. Next, we have what we call as the loops. So loops in Python are basically something that are recursive or iterative, right? I think many of you are familiar with the general for loops and while loops, but let's just take a look at it. So the while loop, with the while loop, we can execute a set of statements as long as the while condition is true. So we have while, and then we have the while keyword, and then we have the condition, right? So while that condition holds true, we execute whatever it is under the while loop. So let's just take a look at the Python notebook. So here we are basically declaring I as a variable with the value 1, right? And then we are using the while keyword, and we are given the condition here. So while this condition holds true, so until I is less than 6, you are doing the following commands. So what is the body of the while loop is that you're printing the I and you are incrementing this. Guys, if you remember in the Python Sprint 2, while we were talking about different operators in Python, this is an incrementing operator, right? I plus or equal to 1 is basically I equal to I plus 1, right? So you're incrementing the value of I by 1. So just let's just see this, right? If we execute this, until I is less than 6, we are printing the value of I, and then we are incrementing it by 1. So you get 2, and then again printing it, right? Until 5. Why did we get till 5? Because when you increment this to 6, right? When you increment after this I equal to 5, when you execute the statement, it's basically I equal to 6. But when I equal to 6, this condition does not hold true, right? I is less than 6. So if I is less than 6 only, until that I equal to 5 value only, these conditions are satisfied. And one more important part in this code is that you have to remember to increment the I value, or else it is going to be what we call as an infinite loop. For example, if I just comment this part, and if I just say I equal to 1, and while I is less than 6, just keep printing I, right? So obviously this condition is going to be held true forever, right? There is no stopping point because we are not incrementing the I value. What will happen here is if I execute this, there you go. We are just getting an infinite loop, guys. So the value 1 is going to keep printing forever until I stop this, right? So it's really important that you take care of this and you just increment the value and then execute it to get the proper output. So after the while loop, we have something called as a break statement. So the break statement is used so that we can stop the loop, or we can basically exit the loop even if the while condition is true, right? So you have a while condition and you are executing certain commands. And what if you, for a particular command, you just want to exit the loop, right? You don't want it to keep continuing forever and ever. So for that, we use what we call as a break statement. For example, so here we declared I as 1, and we have the while loop, and the condition is that I is less than 6. We are basically printing the value of I. And here, under the body of while loop, we are giving an if statement. We print the value of I, and then we check that if the value of I is 3, when this value is incremented and when it reaches 3, just break it, right? We are using the keyword break. So what does this mean? So this, until this condition is true, you're going to keep printing the value of I. But when I reaches 3, you're basically exiting the whole loop and the loop is ended there, right? You just want it to end there. That is why we use the break statement. So obviously you're going to increment the value, because as we saw in the earlier code, if you do not increment this I plus or equal to 1, it will be an infinite loop and it will be continuing forever, right? Let's see what will happen. So there you go. So while I is less than 6, you're basically printing the value of 1 and incrementing it. That's the major general part. But here we have a keyword break under the if statement. So if I reaches the value 3, there you go. The loop is basically stopped there, right? Because you don't want it to continue forever. That's why we use the break statement. And after the break statement, we also have something called as the continue statement. So the continue statement is a slightly different use than the break statement. We use continue keyword when we stop the current iteration. We basically skip the iteration and continue with the next one, right? So if you want to understand what is this iteration and stuff, for example, we have a while loop. We declare the value 0, and we basically giving the while condition that until I is less than 6, you keep incrementing the value of I by 1, right? So this value keeps like 0, 1, 2, etc. But if the value of I is 3, you're giving the keyword continue. This basically means that if the I value reaches 3, you're going to skip it. You don't want to print the I value 3. You're skipping the iteration, that particular iteration. So guys, the difference between continue and break is that in break, if you give break here, it basically exits the loop and the loop is ended there itself, right? So as we saw here in this output, 1, 2, 3, that's it. You're just breaking it there. But in continue, when you're saying that if the I value reaches 3, you're skipping that particular iteration and again starting with the next iteration. For example, there you go. So you have 1 and 2, but when I value reaches 3, right, you're basically saying continue. So just skip the current iteration, do not print 1, directly go to the starting point, and again go with the next value of I. So the next value of I is obviously 4, right? So you have 2, and then 3 is skipped, and then you'll go with 4 and 5 and 6, because the condition is holds true until the I value is less than 6. So that is how the break and continue statements work, right? So again, this is about the while loop and the break and continue statements. Next, we have what we call as the for loop. So guys, the for loop in Python, like any other general object-oriented programming language, is for the major reason we use a for loop in these object-oriented programming languages like Python is for iteration, right? So a for loop is used for iterating over a sequence, that is either iterating through a list, iterating through a tuple or a dictionary or a set or a string. It could be anything. But basically you're going one by one, you're iterating it. So as we already know, we use the for keyword, right? The keyword is for, and unlike other programming languages, it is used as an iterator in object-oriented programming languages. And so with the for loop, we can execute a set of statements once for each item in a list or a tuple or a set. So we are basically executing this. Let's see the example actually. So we have this list that we declared here. So as we saw in the different data types, we know what is a list, right? So the square brackets and stuff. So in this list that we called as fruits, for each value in fruits, so we use the for keyword and the in keyword here. So for each x, right, this x could be I also, it could be any variable. We are basically saying that for each value in this list, so for each x in fruits, you are basically printing the value of x, printing the particular element. Here the x or whatever variable you keep, that represents the particular element in the list. So for x in fruits, you want to print each x, right? So what will happen is you basically get apple, banana, and cherry, right? You're just printing each element or each fruit in the given list. It's a simple for loop, guys. So as we know, this is called as iteration, right? In this particular list, we are executing this print statement for each value of the list. So first you go to apple and then execute the print statement. You go to banana and then execute the print statement. You go to cherry and then execute the print statement. So we get all these three, as you know. So as we already saw, you can even loop the for loop through a string, right? Not only a tuple or a list or a dictionary. Instead of this list here, what if I give a string, right? For example, for x in banana, this banana is not a list or a tuple, guys. This is basically a string, right? As you see the double inverted commas. So we are looping through the letters in the word banana. So as you may have already guessed, we are basically going for each x in banana. That is for each letter in this word. Just keep printing, right? Printing what? Printing each letter. So if you execute this, you'll have what is called as the iteration. So in this particular string, you are basically printing each element or each letter in the word. That is how we use it to iterate through a list or through a tuple or through a string, etc. And as we saw the break statements in the while loop, we also have the same statements in for loop as well, right? And these break and continue statements are a very important part if you know how to use them. So what is the break statement in the for loop? It's the same thing, right? It's the same part, but just we're using it in another scenario. In while loop, as you saw, when we use the break keyword, we are basically exiting the loop, right? So we are just breaking the loop and going on to the ending, right? So it's the same thing. So the break statement is done by using the break keyword, and we can stop the loop before it has looped through all the items. So for example, we say that we declare a list for named fruits and we give 3 values in it. And we are saying that a for loop, right? For each element in this list, you're basically printing the element. So you get apple, banana, and cherry, but you're giving a condition here. If under the for loop, we are having an if statement, right? If you can see carefully. And guys, this indentation, what we have talked about earlier, it's present in each and every code, guys. It's not restricted to the if else part or the for condition or whatever. Anywhere in any code that you take in any scenario of the Python, indentation is a really important part. So we are saying that for each element in this list, you're printing the list, the element, and then you're checking that if X is banana, right? If the particular element is banana, then you're breaking it. So you're just exiting the loop there itself. For example, if we execute this, there you go. So first, the for loop says that you print the element, right? You go to the apple. First element is apple. Apple is printed. And then you check if X is banana, right? Apple is not banana. So you're not breaking anything. You're going again to the for loop part. And the second part is after apple, we have banana. So you're printing banana, we get banana. But if X is banana, if this condition true, right? It is true. When we have X equal to banana, you're breaking it there. You're just exiting the loop and ending it there itself. So the iteration is not continued until the cherry, right? We don't have cherry printed here. Because when X reaches banana, you're breaking it and exiting the loop. That is how you use the break statement in for loops. Again, so for example, there is a small difference between these two codes, guys. If you can observe carefully. Here, what we're doing is in the for loop, we are printing the element and then checking if the X is banana and breaking it. In this particular code, you have a for loop, and here before printing the element, you're checking if X is banana, right? Because you wanted to see if X is banana and then break it there itself before printing banana. For example, what happens if I execute this, right? You just get apple. What is the difference here? So here you're printing the particular element and then checking if the element is equal to banana and then executing the loop. Here, before printing the X, you're actually checking the condition for the if condition, right? If X is banana, then break there itself and do not print it. So that's why in the output we do not get the banana part. We only get the apple, and the banana is basically exited. The iteration is exited there itself. And so then we have the continue statement, just as in the while loop. This is the continue statement for loops. So with the continue statement, again, it's the same use, guys. So continue keyword is used so that we stop the current iteration of the loop and continue with the next iteration. So the present, whatever iteration is there in the present loop, you are stopping it there itself, and you're starting over again from the starting point and going with the next condition. So for example, we have a list of fruits. We have for X in different fruits. You are basically saying that if X is banana, then continue. So in the previous example, if X is banana, we are breaking it here. So the loop is exited and we only get apple. But here you just want to skip the particular banana part. So if X is banana, do not print it, right? You continue. What is continue? You go to the next iteration. So after banana, we have cherry, right? So check if cherry is banana and stuff. It's not banana. So you just print the statements. So here we don't want to print banana. That's why we use the keyword continue. For example, if I run this, there you go. You're getting apple. And then when the iteration goes to the banana part, it is basically continuing. So continuing in the sense we're skipping that particular iteration and starting over again with the cherry part. And cherry is printed. That is the difference between the break and continue statements, guys. So it's the same things for while loops and for loops, but you just have to be careful about these small nuances. Like you have to check whether the indentation is proper, right? And you have to check if you're printing the particular variable before the break statement, or if you want the break statement to come after you print the element. So these small nuances might give you different outputs each time, as we already saw. And you just have to be careful with each of these. So after the continue statement, we have what we call as a range function, right? So this range function is basically, we use this in the for loops usually. So to loop through a set of code, a specific number of times, we use the range function. So the range function returns a sequence of numbers starting from 0. By default, the range takes in the number as the starting point as 0, guys. And by default, it increments each number by one value. It ends at the specified number. Let's see what this means in the Jupyter. So we say that for X in the range 6. So for X in the range 0 to 6, that is 0, 1, 2, 3, 5, 6, you basically print each variable, each value, right? But here, if we print this, if you see carefully, the 6 value, that is the value 6 is not printed. This is because by default, whatever number you specify in this range function as an input, it takes the loop until the number before the value you specify. So note that the range 6 is not the values of 0 to 6, but only the values of 0 to 5. So this is an important statement, right? So if you specify this as 7, you're not getting 7 here. You only get the values from 0 to 6. So the last part or the ending variable, whatever you declare it, the ending point is basically skipped. You'll only get it till the number before the specified ending. And again, in the range function, we can basically give 3 inputs here, guys. So the first is the starting value. This is 2, right? And the second is the ending part. So you're basically saying to print each values from 2 to 30, but the third value, the third input is 3. What is this, right? This is the what we call as the incrementation value or a step count. So we are basically saying that for X in the range from 2 to 30, you're printing X with incrementing each value by 3. For example, let's see what happens, right? So before we execute this, your starting value is 2, and your ending value will not be 30, right? If I just kept this as, if I just kept the step count as 1 by default, and if I just kept the ending value as 30, what I'll get is, you'll get all numbers from 2 to 30, excluding 30, right? You'll only get it till 29, as we saw in the earlier example. But what if so as we saw, the default step count is 1. But what if I give the step count as 3 and then execute this? So what is happening is, from 2 to 30, you are executing each value by incrementing the value by 3. So you get 2 as the starting point, but then you're printing it by incrementing by 3, right? 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11, and so on, till 30, right? How much ever is possible from 2 to 30, excluding 30, by an increment of 3, you're using a for loop and iterating through this range. So that is why we use this range function, especially in for loops. And as we saw the nested if statements, we also have what we call as the nested loops, right? So nested loops is basically a loop inside a loop. So you have an outer loop, that is the main block, and inside the outer loop, we specify an other loop. So as you see, the nested loop is a loop inside a loop, and the inner loop will be executed one time for each iteration of the outer loop. What does this mean, guys? So as you see here, we have two lists, right? One is the adjectives and the second one is fruits. So we have three values each in these both lists. And you're basically saying that for each value for X in the first list, this is the outer loop, guys. This is the outer loop. For each value in the outer loop, which is considered in the adjective list, you go to the inner loop, which is, there is another for, right? This is called as a nested loop. Execute the nested loop here. So for each value, for each value in the adjective loop, you check and iterate through each value in fruits and print both the values, one from X and one from Y. So how does this work is that for, so let's just execute it and see, right? It'll be more easy. So here, first you check the outer loop. The first value in the outer loop is red, right? For this particular value red, for X in adjectives, that is red, you check the fruits list, guys. You basically check the fruits list and iterate through the fruits values. So you have red apple, red banana, and red cherry, right? So that's how you get the first three outputs. And then after this is done, you go out to the outer loop again. And what is the second element in the outer loop? Big, right? And then for this big, you're executing the values of the inner loop again. So big apple, big banana, and big cherry. So that's how it goes, guys. So this statement is very important. The inner loop will be executed one time for each iteration of the outer loop. That's what this means, guys. So basically, it's as I already said, the for loop is basically used for iteration. This iteration is a very important part when you check in the object-oriented programming languages, right? So that's about loops, guys. So till now we have seen different controls, conditional statements, the if, elif, and else part, and then we have seen different keywords like break, continue, and pass statement, right? If you remember the pass statement, it's basically a dummy variable and etc. If you remember it, and then we have the loops. The loops in Python include the while loop and for loop. As you saw, the break and continue statements are used in both the loops in different scenarios. So the for loop, so while is that the while loop is basically for seeing if the condition is true, and until that condition is true, the body of while is executed. And the for loop part use the for keyword, and it's basically used as an iteration, right? For iteration purposes, use for keyword. And then we also have seen what is called as a range function, which we use in for loops. So that's about the control flow part in Python, guys. So yeah, and we also have the nested if statements and nested for loops and etc. Right? So we have an inner loop inside an outer loop, and that's about the control flow in Python, right? This is the basics, and I suggest that each and every one of you just execute a different variable, like just as I did in the Python notebook. You just take different values and just play with these loops and conditional statements, so you'll get to understand them better, right? What if you'll understand what will happen if you don't give an indentation block, or what will happen if you give a break statement after printing the value, or what will happen if you give the break statement before printing the value. Just play with the different codes, guys, not just for the control flow part, But for whatever coding part you're doing, you just have to play and experiment with it. That's how you'll get better at this, right? So that's about the control flow. And now we have functions in Python, right? So for functions in Python, we'll just look at the very basic user-defined function and different keywords in that. We're not going in depth in this session, guys. So yeah, in Python functions, you have basically two different types of functions in Python, guys. One is the default functions, which are Python generated, right? So as you saw the range keyword, right? That is by default, if you just give the keyword range, it takes it as a range function. That is not a user-defined function, right? But you have a second type, which is called as a user-defined function. So you can actually create a function by yourself using this syntax. So for creating a function, you use the def keyword, right? Def is basically the define keyword. You're defining what we call as a function name. If you look at this picture, def keyword, and then you have a function name. So that name could be, anything, right? My function or whatever it is. And then after that, you give it two parentheses. And inside that, you have what is called as the parameters. So the values you use while defining the function are called as parameters. And then you give the colon, and then inside that, after an indentation block, after the def keyword, you give what is called as a docstring. So docstring is basically, I don't know how many of you know this, but in Jupyter Notebook, if you just go to any code and if you just click Shift tab, right, you get what is called as a docstring, guys. So this basically gives the explanation of how, right, you have the syntax or you have the explanation of the particular code. You just keep a cursor here and just click Shift tab, you get the docstring, guys. So that's how this is done. So while defining your own functions, we can give particular description in under the docstring, that is the triple quotes, and then you have particular statements. So you're defining a function name by passing few parameter values, and you are basically saying that you execute the following statements if this function name is called, right? And then you have the return expression, that is option, right? It basically returns the values. So there are two things here. One is creating this function, and the second part is calling the function, right? Let's just take a look at that. So here, I use the def keyword, and then I have the name called as my function. And then the part is that body is that I'm printing this, right? Hello from a function. So if I just execute this, nothing happens because this is basically creating the function. We haven't called the function yet, right? So what is calling a function? So this is calling a function, guys. So under the def keyword, I've given my print statement, and I've also given the docstring here, right? If you see carefully, I gave it under the triple quotes and this docstring. And while calling a function by using the function name and curly brackets, if I execute this, you get the following body, right? But what about docstring? For example, if I keep here and press Shift tab, there you go. For my user-defined function, I get the docstring, that is description of this function, right? This is called, I just gave like, this is a sample function by Pranav. That's how this is run, right? And we also have what we call as return statements or return values. So for a function to return a value, we basically simply use the return statement. So we're defining a my function with a parameter x, and you're returning the x value multiplied by 5 here. So if I just call the function, right, you're printing my function with a different value 5, you're basically getting an output which are multiplied by 5. So if you pass on the parameter 3, it executes the return statement that is multiplied by 5, that is 15, right? That's how this is done. And the last part is called as arguments and parameters, guys. So arguments and parameters is basically, they have the same reference, guys. Arguments or parameters are used for passing values into a function. But the difference is a parameter is a something which we use to pass values while creating the function, guys. So during the function definition, that is we call it as a parameter. And while calling a function, when you give certain values into the function, that is called as an argument. So parameter is basically while creating, right? During the definition part, if you give this x, this is called as a parameter. While calling the function here, if you give 3, right? This 3 is called an argument. And there are two types of arguments here, guys. This is the ending part. So just take hold, guys. The two types of arguments, that is while calling a function, you can give it in two ways. One is the positional arguments. The position arguments, as the name suggests, you have to have them in a proper position or an order, guys. So you just basically define a user-defined function, and you take in two parameters here, first name and second name, right? These are called as parameters. And while calling the function, you're printing it by specifying the first name and last name in that particular order, because while defining the function, we gave it as first name first, and then second name comes second, right? So by default, like Elon and Musk, the Elon is the first name, Musk is the last name, Elon Musk is printed here. So what is keyword argument, right? What if you just want to exchange these values but have the same output? What if you want to give the last name first and the first name second instead of this proper order? What if you want to interchange that but have the same output? You don't want to get the output as Musk Elon, you want the output to be Elon Musk, but you just don't want to call the values in the same way. Then we use something called as a keyword arguments. While calling the function, you basically define the keyword, right? The keyword is basically the argument name, parameter name, guys. So you define the parameter name and give a value. So you can interchange, right? If you see this in this example, we are interchanging first name and last name by giving the keywords here. So it obviously, the function, you're telling the function that take second name as Musk and first name as Elon, but you're giving it in a different order. Then you use keyword arguments, right? So position arguments are basically you follow the same position as you give in the function definition. Same order, but the keyword is that you can exchange by using different keywords. And if I execute this, you'll get the same output, but while calling this, you just have different parts. So we're basically explicitly assigning the values, guys. This is called as the keyword arguments. So this is about user-defined functions in Python, guys. I think this is enough for the basic part in this session. So we have covered about everything from conditional statements, for loop, while loop, and different keywords, nested loops, and that comes under the control flow part. And we've also seen different user-defined functions and different parts like the arguments, parameters. And I hope you're now familiar with what we call as a keyword arguments and a positional arguments. So again, as I said, you just have to play with these codes and then you'll know how each of them are going to come, right? So that's about today's session, guys. Thanks for staying patient. Now I think we'll have the Kahoot session, right? I'll hand over this to Sharon.
Thank you, Pranav. That was a very nice session. So now we are going to play the Kahoot on the today's topic about loops, different types of loops and different types of functions we have learned in today's session. So Sharanya, can you please share your screen? Sharanya, we're going to hand over the Kahoot questions to you.
Yeah, guys, 1 second.
Guys, you can find the ipynb Jupyter files in the chat box. I think Keith has texted in the chat box. Just check it out. So even if you have missed the previous sessions, you have the drive links for them. Just download them and keep playing with the code, guys, so that you can get better at them.
Guys, just a second. She will share you the screen. Guys, you can find the pin on the screen, right? Guys, we have an issue. We'll solve it in 2 minutes. Just hold on. Guys, you can find the pin. Just log in into the Kahoot website or the Kahoot app which you have. Just enter the pin, and I request you guys to please actively participate. Guys, we'll wait for 2 more minutes. Please make sure to enter the right pin. Yes, guys, I think we can start the Kahoot session now. Sharanya, can you please start it? How many types of control structures does Python support? One answer. Two. Next, we have Sandhya at the top, Sriharsha at second. Okay, next. Guys, make sure you keep in mind about the time. We have again Sandhya at the first and Sriharsha at second place. Okay, next question. Okay, next. Oh, now Sriharsha has reached the top place. Next. Next question. Okay, next. Okay, next. And next. Good. Next. That's it, guys. I think we are waiting for the results. Stargazer, and we have Coda 123. And we have Sri Harsha standing in the first position. Thank you, guys. Congratulations. Guys, I hope this session was good and it was understandable to you people. And I also hope that you people have gained a lot of knowledge from the 3 basic Python sessions. Now I would hand over this session to Ashwin Bharat, our chapter lead.
Yeah. Okay, so I would say that session was really great. So I'd like to thank the data science team from JU chapter for this amazing event. And I'm leaving a link in the chat, guys. So all of the resources as well as the Python blogs I've written in the past might be really helpful for you. You can check out our chapter page where we'll be also uploading the screenshots, PPT as well as the recordings later. So make sure you check out this link which I have shared, and as well as for the next upcoming data science track, we have also added them in our chapter. So make sure you go through the chapter link as well. Let me post it in the chat box. Okay. Great. Okay, then so let's wrap up over here. Thank you guys for joining.